Welcome back to DC Thursday, everyone. I'm Pete Soderling. I'm the founder of Data Council and the Data Community Fund. And I am excited to be your guide through the crazy, sprawling, expanding modern data ecosystem. As you know, we have regular guests on the show who are typically open source data tools contributors or authors, or startup founders in the data ecosystem. And today I'm very excited to welcome Ori Rafael, who's the co-founder and CEO of Upsolver. So Ori, welcome to the show.
Thanks, Pete. Great to be here. Thank you for having me.
So Ori, I want to get started and talk a little bit about your background, which is something we typically do on the show. Talk to us a little bit about your early career and how you got into data.
Well, my early career, my first job was in Israel. I went to the army for 6 years, and I spent that time in the Israeli intelligence. And my first job was a database engineer. So I started as kind of a person in this community. I was given the choice between engineering and data, and I chose data and never looked back. We had thousands of database instances, so we had quite a decent scale. Our DBA team was very big, and we're basically the pivot point around all data analysis. So it was a very interesting first position for me at the age of 21.
And this is probably, is this the days of Oracle, when Oracle was big, or did you use something else?
Oracle and SQL Server at the time.
Okay, got it.
Oracle was the biggest for us, and I started with Oracle.
Got it. And did you start to use open source data tools at some point following that?
Yeah, so we've evaluated Hadoop in different ways, but it always was, I would say, more on the marginal side. And after that, when the NoSQL started, so we've used Cassandra and we used Elastic and Redis and like a whole bunch of open sources.
Got it. And what were some of the key learnings from the early part in your career? How long did you spend in Israeli intelligence, by the way?
I spent 6 years, actually 7 years eventually. I finished leading all of their data integration. So started in databases, eventually went back more to ESB or to ETL, depending on the time. What are some of my key takeaways, key insights? Well, it's a very big question, I think. I started, my first days were Oracle days. So, everything would be solved with an Oracle. And I remember learning by hand that it's hard to be locked to one vendor. Like you have to use it, even if it's not the right tool, you have to pay a lot, you're kind of dependent when there are bugs. I think every person in my team had bugs listed under their names in Oracle. We really took Oracle to the extreme because it was still an RDBMS, a traditional RDBMS, and we had significant amount of scale and also use cases. So I really remember those early days in the DBA as a DBA, but also remember that so many different users in the intelligence use the databases directly. Technical, by the way, and very semi-technical. And Hadoop was always kind of on the side, something for some expert that some remote team would operate. And I remember a lot how much databases allowed us to iterate fast. And every time that I come to a problem, I usually first think about it in database terms and not in code terms. So SQL is very natural for me, and it was natural for a huge amount of users, which is something that I took away from my experience there.
Yeah, got it. That makes sense. And where did you go from the Israeli army?
Well, I spent a few years. I wanted to really have my own startup. So I felt like coming out of the army, which is a non-profit organization, I needed to better understand what's going on in the market and why companies act as they act. So I did 3 years of B2B sales, and then I founded Upsolver.
Okay, got it. Awesome. Well, I'm excited to chat with you about Upsolver later in the show, and want to understand what you're building there and some cool things about the product. But before we do that, I wanted to ask you about this open lakehouse concept. I know it's something that you've been talking about and you've been writing about. You have a blog post on it that that I was able to check out. Sort of what's the big deal? First of all, with the lake house. Lake house sounds like we're Frankensteining a couple words together, a couple concepts together, as sometimes we do in technology. Is this literally a combination of a data lake and a cloud data warehouse, or how should we think about like what does lake house mean?
Well, I understand the confusion completely. I think that you can decide that Lakehouse is a database. In that case, it will be closer to your house, and you can decide that it's an architecture, and in that sense, it will be closer to a data lake. I think that companies like Snowflake are interpreting Lakehouse as a database. So basically a database built on Lake foundation, but it's a database just like Oracle, like it's a closed box, internal storage and compute, proprietary storage. So everything is very specific to Snowflake, but it's built on Lake infrastructure, which make it easier to handle and more scalable. On the other side, there is the data lake of the world. And data lake is, of course, built on data lake infrastructure, but is it a house? Is it usable? Is it easily queryable? All of that usability has always been a challenge for the data lakes of the world. So a person thinking about the lake house as a data lake, they want to make the cost-effective lake usable. A person from the house, they want to make the easy-to-use house scalable and more cost-effective. And I think different companies are interpreting the term lakehouse in different way. I interpret that as, and that's why I added the word open. I interpret it as a lake. So I think storage is the most important piece in the database. That's what's going to dictate your performance and cost and maintenance. So giving that, I think that taking the data lake that didn't succeed in the past, but gave all of those benefits and just make it usable is the right way to go.
Got it. Well, it's for sure. There's a lot of there's lack of efficiency and there's challenges around data lake architectures historically. So it seems like, you know, maybe we have a sort of a reference implementation of a data warehouse a la Snowflake or Redshift that seem and sort of feel to be more battle tested and industry, you know, seeing industry-wide adoption. But maybe on the data lake side, we're a little further behind in actually understanding a mature implementation of a data lake. So I don't know if you would say that the lakehouse is some sort of advancement of you know, some of the older legacy concepts in a data lake sort of brought into the modern era, if you would agree with that or not.
I would agree with that. I think that I would definitely agree with that. I think that data lake is more, it's harder to implement because it's an architecture and not a single product. So I'm not getting one box. On the one side, you have ingested. On the other side, you have SQL. That's basically a database. And it's easy to understand for the organization. If you look at the architecture diagram, usually there is one thing. And if you look at the data lake, you need to stitch together the solution from multiple things, multiple services. That, of course, adds management complexity. Is it a bad thing? Well, if I would say it's a bad thing, I would also have to say that microservices is a bad thing because it's harder to manage a bunch of microservices comparing to managing one monolith. Of course, it's harder to do, but what are the benefits? I think that there's a lot of similarity between the idea, the concept of an open lakehouse and the concept of microservices. Let's give different smaller services. Let's not be tied to one vendor. Let's be able to scale each server elastically. Let's not be so locked as we are to databases, something that I've felt in my early career. So this is the way I'm thinking about it.
I see. So then to extend that, I like that analogy. So essentially what you're saying also conversely, or as an extension of that, is that the data warehouse model is actually more similar to the monolith database model, where you're sort of talking to one vendor for everything from, you know, query to compute to storage. So perhaps your argument then is that the data warehouse even of today is very much a monolith, whereas the data lake is much more like a microservices sort of decoupled architecture.
Completely. I completely stand behind that. And like, even look at the website for some of the big companies. So look at Databricks. For a long time, it was Unified Analytics Platform. Unified means that you use data, you use that tool. And also for Snowflake, they have, you see Snowflake Compute Engine and a whole bunch of use cases on top. So you have data lake, data warehouse, data engineering, so all of them. And it's great, but eventually, why do you have to use Snowflake Compute? Because you're using Snowflake storage. And what if when it says data lake on top of Snowflake there, maybe that's not the tool that you want. I'm not saying that they're not doing a good job. Maybe that's not the best tool for you, for your preference, for your users. What are you doing? You're kind of stuck. Like you don't have another option. So Snowflake is a great tool, but eventually it's the same as Oracle. Same dynamics I had with Oracle 15 years ago is the same dynamic users have with it. And I loved Oracle. I enjoyed working with it, but there was some limitations.
Got it. Well, let's talk about on the data lake side or the lakehouse side. What are some of the challenges that you see that folks typically have in sort of getting efficiency out of their data lake architectures? Before we talk about the open standard that you're proposing, let's talk a little bit about some of the real world challenges on the lake side of the house, so to speak.
Yeah. So the problems on the lake side can be from data correctness to performance. And the reason is that like a database really kept you safe. So I did insert, update, delete, and then I communicated with the table. And underneath that table, there was some kind of file system that I wasn't aware of. I didn't try it. I didn't need to manage it. I didn't need to make sure it's correct. Like everything, I trusted Oracle to give me that. Now I'm working with a data lake, and basically I'm writing code on top of a raw file system. So this is why databases were invented, so people wouldn't screw up all their entire file system. So that's why the engineering on the data lake side is one, more complex, and second, riskier. Like you have to do what you're doing because you're basically putting on your shoulders the same responsibility you once gave to Oracle, which is they're pretty good at doing this kind of work. So I feel like that understanding how to build a proper file system, how to partition it, what file formats to use, what compression, file sizes, all of that is on the company implementing the data lake, and they need to know how to do that. And the second thing is how to manage the human process. And what I've seen, at least before Upsolver, is that you have a data analyst team, you have a data science team, and you have a core data engineering team. And you trust your core data engineering team with the risky and complex operation, which was kind of a problem to then get that work into the heads of the analysts and the scientists. You're kind of stuck only at core data engineers. And like my experience with core data engineers, they're super hard to get and their time is super valuable. So definitely this is not the thing that I want to spend their time on. So I think giving access to the data to all those database users is something very, very important to do and a little missing with data lake today. That's data lake 3.0. Let's give it the same access we gave to the same level of access we had in databases.
Got it. So so what about the so-called open or open source data lake formats? Right there's Delta Lake, there's Iceberg, there's Hudi, there's a bunch of formats that are in the open source on the data lake side. I think you don't necessarily see all those formats as necessarily as open, perhaps as their name belies. Talk to us a little bit about that.
Yeah. So first of all, if you look at there is a difference between a Hudi, an Apache Hudi coming from Uber, and an Iceberg coming from Netflix, and a Delta Lake coming from Databricks.
Okay.
Netflix and Uber have different incentives. So basically, they have built a metadata store that gives more capabilities comparing to the traditional Hive metadata store. And they wanted to do it in order to add ACID compliance, insert, update, delete, and those kind of things into a data lake. And they open source it. So every person that's going to use that metadata store will have those capabilities. And the only problem I can see is that it's not as well adapted or strongly adapted as a Hive metastore. So usually there is a compatibility issue with using one of those tools. Delta Lake is a different story. Delta Lake is basically Databricks format for a data lake that also solve the same types of problem. But Delta Lake is partially open source, not fully open source. And it still has the same compatibility issues. So if a query engine didn't find the right way to integrate with Delta Lake, then you can't really use Delta Lake. For example, Athena Delta Lake connectivity is something that's been talked about in a lot of blogs. And usually, what you need to do is to spin up an additional integration between your Delta Lake and the Glue catalog, so an Athena will be able to read it, and that's kind of doing going in a kind of convoluted way. So I feel the need is there. People need more capabilities out of their Hive metastores. The update, the delete, the ACID, there is a big need around it. And I feel like this is maybe the area where the data lake market needs to mature the most. Do I think there is a solution in the market today? Not yet, still a little early. And like I would put Delta Lake, by the way, I would put them in the same bucket as Snowflake. They're creating a file system that's very specific to Databricks, and most of the users, like I can't of course say the statistics as Databricks, but I've heard over 80%. And again, not saying that this is well back, this is word of mouth. So I heard more than 80% of the people using Delta Lake are versus using Databricks. So it's a very similar play to what Snowflake is doing, and I'm sure you've seen all the news around Snowflake and Databricks competition. So they're competing because Delta Lake is a competitive move versus Snowflake, and it's more kind of the traditional data warehouse than it is an open data lake, in my humble opinion.
So you're arguing that we need this notion of an open cloud data lake or open cloud lakehouse based on these types of sort of tightly coupled interactions, even in certain kinds of data lake architectures. So talk to us about the principles of this open lakehouse that you're proposing, because I think this is really interesting.
So an open lakehouse has three layers. It has the engines that are building into that are writing into the lakehouse. There are the engines that are querying, and in the middle you have your data store. And I think if I would need to define what's an open lakehouse, if you're using open source storage format like Apache Parquet or C, and you're using an open source metadata store like the AWS Glue Data Catalog or the Apache Hive Metastore, then you're good. Like all query engines are able to query that data. So of course on object storage, I didn't mention that. So Parquet on S3 with a table mapped to it from the Glue catalog, that would be an open lakehouse. There is no engine in the world, no query engine in the world that would not be able to consume that data. That's the most.
So it doesn't matter if you're Athena or Presto or even Snowflake. You can query that file format that on the object storage directly from any compatible query engine, because the file storage itself is based on it's based on open formats.
Yeah, and think about the potential of data sharing between engines. Like one of our public case studies on AWS, one of Upsolver's public case studies is a company named Iron Source. They have a velocity of 3 million events per second, which is a lot of data. And then they are using 3 different query engines at the same time on the same copy of data. So BI liked one thing, and the analytics team liked one thing, and the data science team liked one thing, and maybe the cost would made sense with one tool in the beginning of their journey, but then they decided to move to another tool because they wanted to have their own cluster. So things evolve, and if all the query engines can share the same copy of the data, you get a lot more agility, and you don't have the same Oracle locking that we had 15 years ago.
And what are your opinions on the storage layer options? How do you compare formats, and sort of any insights on how a team might pick the correct open format for their storage?
So it's usually a discussion between Apache Parquet and Apache ORC. So there isn't a lot of depth to it. Every time we've tried to check whether one is better than the other, we've found marginal differences and use case dependent. We decided to standardize on Apache Parquet because it is more common, and because we haven't seen big differences when you're using ORC. So we prefer Parquet. but it's not based on the fact that OSI is not good. It was just more popular.
Got it. And how popular do you think this open cloud lakehouse format is becoming? You obviously feel like the world is ready for it. You're out talking about it and evangelizing it. Are you seeing the adoption sort of tick up in the way that you would hope?
Yeah, for sure. This is the golden age of query engines. So in the past, like you needed to spin your own Presto on, on something like an EMR. Like you needed a cluster to manage every time. And now you have Athena, and Athena is a very well adapted service for AWS. So the number of Athena users, the number of companies using that service, I think it's one of the AWS's most fast-growing services, and that's a good sign. You can see Starburst and their success and their recent fundraising. You can see Dremio. You can see Snowflake, BigQuery, Redshift, and Azure Synapse, all having independent query engines that query open source data. So like if I needed to make the list of options for query engines 3 years ago, I would have 1, 2, and they weren't very easy. And now I have like 10. So I think we're going to see more and more query engines, and we're also going to see query engines that are more use case specific. Like for example, if I could query the data from S3 and get Apache Druid-like performance, that's a very nice service. I don't need to get all my data into Druid, which is the hard part, and I still get a very low latency on top of S3. So that could be a query engine that adds indexing into it. That's an example of a startup. You can have a query engine that reads the data and follows the Elasticsearch pattern or the Cassandra pattern. So I kind of see this open lakehouse concept as you have your store on S3, you own it. You as the customer, you own that store, and on top of that store, you have a whole bunch of APIs. You have an SQL API, you have a low latency SQL API, you have an Elastic API, and NoSQL. So all the databases that we know, I think that eventually they're APIs to data, and the data should be decoupled away from them. That's kind of 5-10 years from now.
Yeah, I like that vision. I think you're right. It is a golden era for query engines, and this format could potentially make a lot of sense. I want to go to a question because Daniel has jumped in with a question. How do you handle, in Scala terms, covariant needs? All engines can read it, and contravariant needs, meaning Dask needs metadata not in other formats to get good performance on the system. Do you have any thoughts on that?
Can you repeat the covariance you said? Maybe I misunderstood what he said.
I think he's using Scala terms. How do you handle covariant needs and contravariant needs? I guess I'm not as familiar with the term.
Yeah, same here.
But maybe Daniel can jump in and clarify. His example is regarding where a contravariant system is like Dask that needs metadata not in other formats to get good performance on the system.
Yeah, I think I understand I hope that I understand what he's saying. And he is right that one of the big caveats of getting data directly from an object store like S3 is the low latency performance. So you need to go to the metadata store, the high-meta store, which is basically MySQL, and then I need to query it, get the data back, go to the files, look in the Parquet files, understand which one I need to open. So there's a lot of metadata round trips there is every time you go to a Presto, there is a fine that you need to pay in the beginning before you can. That's kind of there's a disconnect from real-time dashboarding. And Daniel is right, and I think one of I said that metadata stores, I see them as still a little early. We need to push the same level of statistics we had in databases into metadata stores, and that's why we wouldn't need to go to every single Parquet file. There's a lot of room for optimization there, and I also think that Dremio and Starburst are already doing some of that work. I completely acknowledge what Daniel is saying. This is a challenge. I think that once all query engine will be able to do sub-second queries from S3, that's going to close a big gap comparing to traditional databases.
Very interesting. So I kind of want to touch on the third part of the architecture that you mentioned, because we talked about the storage and we talked about the query engine layer. But this sort of is a bridge into talking a little bit more about what Upsolver does, because obviously the data has to get into the lake or the warehouse in some way in the first place. And I know you have some thoughts on that, but tell us a little bit, first of all, about what Upsolver does and why you decided to start the company and how that might fit in.
So, but I met my partner for Upsolver in the Israeli intelligence. I think he was the CTO of the largest data science group in the entire army at the time. We both knew databases very well, and we decided to work on a problem in the advertising space. By the way, the advertising space and the intelligence space are pretty similar. You're trying to understand what people are doing. So we started there, but there was big amounts of data. We needed to do a lot of machine learning. So two things pushed us to choose a data lake. The first was cost, because the volume. The second is machine learning, which is not a well-suited use case for a database. So we looked at the tasks that we needed to do. And I remember looking at some kind of analytics breakthrough we needed to do on traffic. And I said, this would take me 3 hours to do in SQL as a DBA myself. And then we needed to go find a data engineer, which was hard because it wasn't such interesting work to do. And when we brought that person, it took them about 30 days to do that with Spark. So what brought me into this business is that I think that I want to turn data lakes to be more like databases with their time to value. And that's a pain I had experienced personally. And we actually built internal tools for ourselves, so we would be able to iterate faster on top of S3, and eventually decided to turn those tools into Upsolver. So we see ourselves as, I hope at least, so we see ourselves as our own users, and we can relate to any person coming from the database world into the data lake world, and that's why we started the company.
So it's very much a contrasting approach from using the old Hadoop and Spark tools. So that's based on your familiarity and love and appreciation for SQL and belief that data engineers could benefit from simpler tools to move the data through their systems.
For sure. So yeah, so I think that back in the Hadoop days, some would call data lake a science experience, or something you do for your use case with too much data when you're only thinking about cost and you don't care about usability. And I think in the last few years, we have been proven that the future of databases is data lake infrastructure. This is not a science experiment. Like we need to store data on object storage. So now it's not that people that are early adopting, like doing a science experience with Hadoop, that are moving now into Spark. Those are all the database people that are also moving to a data lake. They don't know Hadoop, they don't know Spark. They come from databases, but they have the same needs. We need to build a data store on top of data lake infrastructure, on top of object storage. Preferably in the cloud. How are we going to do that? We are not speaking the language of Hadoop, and we are not really interested in doing that. This is not promoting the value of the business. The value of the business is to get insights out of data. That's our crowd.
Well, that's a fascinating vision. So you see all the DBAs in the world essentially moving to object storage on the cloud, and yes, they're going to need to learn some new tools and understand the difference between the query engines. And as you mentioned before, there needs to be some advancements there. But your argument is that the data lake is essentially poised to become the new database of the cloud.
Yeah. I'm not even doubtful. Like I've been trying to not say things that I'm not qualified to say. Like, data lake is definitely going to be the data store for all databases. There's no doubt about it.
But yet data lakes will continue to live in parallel with data warehouses, or how do you see sort of that emerging over time?
So when I say data lake, let's try to not confuse the audience in that sense. So when I say a data lake infrastructure, I mean, let's call it object storage from now on. So I see all warehouses running on object storage, and I see all lakes coming working on object storage. So once you're moving to object storage, that's basically changing the way a database works with local storage and replication copies and all of that. So that's the change. What I mean that's going to happen. Will data lakes and data warehouse coexist? I feel like there is no other option. Like if I'm going to use only a warehouse, that I'm stuck I'm stuck with the Oracle lock-in. It's the same problem. So I don't want to do that. I want to use the data lake, but maybe the data lake doesn't work with my use case end to end because it's not usable enough. But then I'm putting a data lake before my warehouse as a staging area. And I'm putting only the relevant data in the warehouse. And then I'm also not locked in the warehouse. So my data is in the lake. And the obvious question is, if all my data is in the lake, can't I query it there? Well, you can. There are some limitations. Over time, those limitations are going to be less and less limitation. So I think the warehouse and lake are already coexist today, as the lake is a staging area before the warehouse. And I believe that we are going to see more and more analytics use cases happening directly in the lake, because why send the data somewhere else? And like the warehouses of the world are already giving an answer for it in this form of a query engine that can work on external stores, in the form of external tables, in a sense.
Yeah, especially if, as you're saying, some of the optimizations can be handled at the query layer for different kinds of analytical use cases. I mean, there might be some limitations there because typically an integrated sort of special purpose database for analytics will sort of control the format of the data on the disk and do query optimization. So perhaps there may be some limitations in the decoupling of the query and the storage, and what can actually only be affected on the query layer. But I guess we'll see over time, how that model shakes out.
Yeah, probably the query, the piece that the query engine can add is indexing. They're not changing the data because the data is shared by others. They're not allowed to do that, but they're adding their index. And then when they query, sometimes they query their index, sometimes they query the raw data that's available for everyone. And that's actually something I've seen with several companies.
Yeah, for sure. Well, going back to this SQL ETL use case, talk to us about common use cases that sort of you see emerge surrounding this SQL ETL pattern. I'm curious to hear more about how companies use that.
Yeah, so let me start with the why. So I have the Hadoop person going to the data lake, the cloud data lake. They're moving from Hadoop to Spark. So Java changed to Java and Scala. Python, there is a change there, but it's basically the same interaction. But for the DBA person or the database database practitioner can be an engineer and analyst. They're not going to write that code, and they don't know all the best practices. They do understand SQL. That's something very familiar for them. So what Upsolver did is basically created a SQL language for ETL. And so every phrase that you're going to see there is probably going to be, I have this source column and I have this target column, and probably I'm going to apply more transformation on the source to get it into the target. The reason we chose SQL is, first, people already have like experience with SQL. So if they want to do the transformation, they're going to go to Upsolver and say, should I learn this company's new user experience regardless of how good it is, or can I use the knowledge I already have to write transformation? That was the first reason to have SQL. And once we did that, we saw a flow of data analyst users, for example, working with Upsolver. So people that wouldn't do it before, because SQL is really their language. The second reason is to show that the system is powerful enough. So you're looking at this tool from a company called Upsolver, and well, can this really do my use case? Or this is a nice visual UI, and eventually I'm gonna get to a glass ceiling. And what we did is that we gave the full power of SQL. So you can do ETL joins and ETL aggregations and time windows. So kind of every possible operation you can do in a database, you can do at the ETL layer with Upsolver. It spoke for expressiveness, and it made us, I think it was adding SQL to our platform was maybe one of the biggest releases we've ever done, and it impacted go-to-market almost immediately because of those reasons, because it became easier and it was clear to explain why is it powerful.
That's really neat. So you use the SQL for the transformation of the data as well. Is this sort of competitive to dbt in that sense? Well, just hang on. Let me reconnect the stream.
Pete, I'm not sure that I can hear you right now. The last thing I heard is you asked me about DBT and Upsolver, because we're both SQL based. Did you get my answer, or you want me to reiterate?
Yeah, could you reiterate that? Because I missed that. We had some technical difficulties here. Sorry about that.
No problem. So I think the DBT and Upsolver are solving a problem in a similar way, but on different parts of the ecosystem. So DBT plugs on top of your warehouse. You're getting a very powerful compute engine from your cloud warehouse, and DBT helps you orchestrate work on top of that engine. So you're writing SQL and you orchestrate jobs, and you're using the SQL you already know, same concept as Upsolver. Upsolver works on top of object store, on top of S3. We don't have a compute engine to push down the SQL to, so we need to parse and execute that SQL ourselves. So Upsolver, I think, built at least a half of the logic that you have to have in a database just to compute the SQL. And if you want to do transformations on top of S3 in the lake, you're going to use Upsolver. If you're going to do transformation within the warehouse, you're going to use DBT. Similar thing, but the question where you want to run your transformation, and of course there are advantages and disadvantages on both sides.
And what are the advantages to doing the transformations over the object storage itself?
Cost would be much lower compared to like order of magnitude level of lower cost. ETLs are not very cost effective when they run on warehouses. The second is latency. So the way you process data in warehouses is that you're basically running SQLs on chunks of data. And what Upsolver does is processing each event separately. So we can deliver the final data within a
third time is the charm, for sure.
Yeah. So just to answer what you said, so I told you that cost is one thing, latency is a second thing. I think some people would like to do I think that the more traditional analysts might like to do the transformation within their warehouse. So that's how we used to work in Oracle. That's also what creates the lock-in, because the final data, the refined data that you're creating in the end, it's only available within the databases. You're not creating that refined level in the beginning, so you're not able to send it to other databases. It's only within your cloud warehouse. Advantages on this side: cost, lock-in, latency. Advantages on the other side. This is kind of how people were used to do stuff in Oracle, which is good and familiar.
Yep, got it. Well, I want to switch gears a little bit, because I know that just from a sort of engineer founder perspective, there's always challenges, especially in going to market. Upsolver is a really interesting tool. It's almost something that's so unique that maybe people have never seen it before, or they've never thought it was possible, because it sort of carves out a new space in the data workflow. With sort of an old standard tool, SQL, but it's basically creating new space. I'm just wondering, like from a founder CEO perspective, what were some of the biggest lessons you learned from bringing Upsolver to market?
I think the biggest lesson by far is that you need to measure and attack friction at every level possible. And I'll make it more concrete. I remember getting started how do you deploy Upsolver? Are you using it as a cloud service, or are you using it as a private VPC, in your own private VPC? That was the question. In 2017, this was a legitimate question. So no one was, private VPC was not that well, was not that popular back at the time. And the team said, well, you can go to the security team and explain and do everything, but explaining takes a lot of time. We don't have time and effort and money to actually go ahead and explain. So I think that from a product perspective, we've been looking at product to sell from day one and seeing how can people start using it with asking as few questions as possible and also avoiding those friction points. And I think SQL was another one. Like I've heard analysts say after POCs, well, it's very nice what you've built here, but I know SQL. This is the language of databases. Why are you serving me with something new? And I heard that feedback a couple of times before we decided to work on SQL. And I have a list of about 10 things in Upsolver that I feel we've built just to eliminate friction, even though we could be considered right, but right isn't winning. That's kind of the biggest lesson.
Yeah, got it. Yeah, well, fascinating lessons with these innovative products. But yeah, it's really interesting to hear your story, Ori. I'm curious, like, what's your vision for this open lakehouse concept? What sorts of feedback and involvement are you looking for from the community on this?
Well, I hope that people will get educated on what's an open lakehouse. They're going to look at their architecture. So, well, this is following a good design pattern. I want to get an open lakehouse because that's what I believe in. I think that I want to future-proof. I want to be able to work with multiple engines. I want to reduce costs, and I understand what it's costing me. And I hope that the people on the other side, taking a data warehouse all the way, will also understand the other options. So I hope that what people are going to get just from that open lakehouse content that we are creating is that they get educated. And I think people are very thirsty to get to know that information. So how do I architect for the cloud? How is analytics different in the cloud? What options that I have that I didn't have in the on-premise day? What's a good reference architecture? What's a bad? How did other companies do that? I think all of that information is very important and in demand. I hope we'll be able to address it.
Yeah, well, it's very important, as you say, for engineers and implementers to understand sort of the differences in the tools that they're using and how they fundamentally work. And so, it's very hard to make these decisions without a clear understanding and education, understanding sort of some of the design patterns and architectural differences and how these tools work. So, yeah, it's been really fascinating to have this conversation with you and to kind of deconstruct some of the aspects of what an open lakehouse means. Yeah, really appreciate you taking the time and chatting with us. And I'm curious, if folks want to try Upsolver as well, where can they do that?
Well, they have several options. The first one is go to the website, click on Start Free, and just work with the platform. There's a community edition, which is free forever with all features except scale, because we would need to pay for that. But other than that, you can use everything. And we have a few quick starts, and and they can start and experiment the platform on their own. That's option one. Option two is that we have dev days on a monthly basis, and on dev days we are giving guided hands-on labs on how to take a use case and implement it in Upsolver. Today in the AWS cloud, in the future also in the Azure cloud, and then Google Cloud as well. And basically you're building something that's end-to-end, not just in Upsolver. You're taking data that's just dumped on object storage and eventually making it queryable in SQL, and you do everything in 90 minutes on your own. So
that's very cool.
Thank you. Yeah, dev day has been popular. So that's option number two. Option number three, talk to us.
Yeah, awesome. Well, we have another question actually from the audience that I want to take before we sign off, or if you have the time.
Sure.
So Manu is asking, what's the minimal POC footprint for Upsolver? If I want to try on my own super private data, what's the simplest and fastest way to try Upsolver?
Well, he said simple and super private data.
Super private,
so,
yeah.
Yes. So for the super private data, I would do a private VPC POC. So when you go into the platform after you sign up, there is a CloudFormation script that we launch, and you can. I'm assuming that it's AWS. There's the same on Azure. So once you do that, you can choose private VPC, and then
Okay.
Upsolver will be deployed into your account. The way it works is that we are able to manage the cluster in Manu's account. So basically spin up and spin down EC2 instances, but our employees don't get access to the S3 bucket. So we can never access the S3, and we cannot even access the instances. So Manu is guaranteed on the AWS level that we will not touch their data, but he will be able to play with Upsolver. That's the concept.
Great. Awesome. Well, that sounds great. And Ori, if folks have other questions for you, what's the best way that they can reach out to you? I don't think you're on Twitter, are you?
I think that I am on Twitter.
Are you? Okay.
Not using it enough, but yeah, Ori, ORI at upsolver.com.
Great.
I always answer my email, LinkedIn, Twitter, all of them works. Start with email.
Awesome.
That's the best one.
Awesome. Well, we're happy to help you advertise this open cloud lakehouse format. I think it's super interesting and a thoughtful architecture that more folks need to consider. So yeah, I was really grateful that you took the time to come and share with us today. And we'll continue to send feedback from our community and send folks directly to you in case they're interested in being helpful or joining any sort of consortium that I think you might be interested sort of secretly in starting.
Sounds good.
Yeah, well, thanks for joining us, Ori. We'll talk to you soon.
Bye-bye.
And to everyone else out there, thanks for your patience with our minor technical difficulties today. I'm glad you stayed tuned in to the end of the show. Next week, we'll have another awesome guest on DC Thursday, and we'll be talking to Tom Baines from Soda Data. He's the co-founder and CTO about data monitoring. So don't miss that episode. Don't forget to subscribe to the YouTube channel, hit the bell icon to get notifications about our next episodes. And we'll look forward to seeing you soon next week here on DC Thursday. Thanks, everyone.